Hello everyone, this is Miss Chelsea and today we'll be discussing physical and chemical changes. Our current standard is S8P1D, which is to construct an argument based on observational evidence to support the claim that when a change in a substance occurs, it can be classified as either chemical or physical. A physical change affects one or more properties of a substance but does not cause a change in identity. The appearance, shape, or size can be changed when matter undergoes a physical change. Most physical changes are reversible because the identity of the matter is not changed, only the form. That means you have the same chemical composition before and after. Examples of physical changes include chocolate melting, sugar dissolving in coffee, folding a piece of paper, boiling water, cutting string, and so on. All of these changes will result in the substance maintaining its identity. So pause the video and try this answer. Give me an example of how a physical property of a substance can change without changing its identity. My example might be you change its mass by pulling a piece off, you change its shape by bending it, maybe you change the state by heating it up, things like that. A chemical change, on the other hand, occurs when one or more substances change into new substances. The properties and identities of these new substances differ from the original substances. A chemical change occurs when bonds are broken and new bonds form during a chemical reaction. Now, most chemical changes are not reversible, but some are. Now, how can you tell if a chemical change has occurred? Well, these are the same indicators of a chemical reaction occurring. It includes a change in color. I don't mean mix red and blue to make purple. I mean like mix red and blue and you somehow get green or clear or something like that. Also, sound. Sometimes a sound is produced, like a hissing noise. Producing light. So if you start burning a match, that light shows you a chemical reaction occurred. Producing an odor, so a smell. That's why rotting is considered a chemical change. Production of gas, fizzing or foaming. Changing energy. So if you're touching the container and it feels hot or cold, that's energy transformation. Also, forming a precipitate, which is an insoluble solid. So if a solid forms from two liquids and falls to the bottom, that is also an indicator of a chemical change. Now, pause the video, try this example, label the following examples as physical or chemical changes. First off, burning paper is chemical because you have the light, you have the heat, you have the sound, you have the smell. Melting butter, that's physical. So if you do it right, you can put it in the fridge and unmelt it. It won't look the same, but it will still be the same substance. Baking a cake is chemical. It requires the heat and it produces steam. So that means it's got gas forming, coming off. And that steam could be physical or could be chemical depending on if you're looking what you're looking at, but in this case it is chemical because you're making a new substance. You can't unbake a cake. So what about digesting food? Well, that is chemical because you're breaking apart the bonds when you digest the food. Freezing water is physical. You can definitely unfreeze water, and frozen water is just ice, which is water with a different structure. Lastly, breaking a glass or cup is physical. If you tried really hard and collected all those tiny pieces, you could glue them back together. So thinking back to the Kool-Aid mixture, you added a powder to water in order to make Kool-Aid. Could this solution be separated? And would it require a physical or chemical change? Please explain.